Okay, welcome back Algebra 2 students. So, in this video we're going to cover section 2.1 where we're solving linear systems using substitution. So, to solve problems like this, we want to take what one of our variables is defined as. Thankfully all of these are isolated, but what we want to do is take the simplest one, in this case it would be z is equal to 4, and we want to take this 4 and we want to substitute it into the other two equations. Now, in this case, z is equal to 4. We only have one z in the top equation, and we don't even have a z in the bottom equation. So let's see what happens when we take z is equal to 4 and put that up here in this first equation. If we do that, we're going to get 4 is equal to negative 4x plus 3y plus 13. Okay, we have this new equation, and it's only in terms in x and y. And then notice that we're also given that y is equal to negative 2x plus 7. What we want to do is then replace the y in this new equation right here with negative 2x plus 7. What that's going to do is that's going to give us another equation only in terms of x. And so doing that, we get 4 is equal to negative 4x plus 3, but instead of writing y, I'm going to write negative 2x plus 7, and then that's going to be plus 13. And so now we have this whole equation here. We have to distribute this 3 and combine like terms, but what we're going to do is we're going to be able to get x by itself from here. If I drop down that 4 and the minus 4x, and I distribute the 3 times negative 2x is going to be negative 6x, and then 3 times 7 is going to be 21, and then we have plus 13. If we combine like terms, we have 4 is equal to negative 4x minus 6x, which is going to be negative 10x. And then on this side, we also have 21 plus 13. If we throw that into our calculator, we're going to get 34. And now we can subtract 34 from both sides. If we subtract 34 from both sides, it's going to cancel, and we're going to get negative 30 over here is equal to negative 10x. And then to get x by itself, we want to divide by negative 10. Divide by negative 10, divide by negative 10. That cancels, and we're going to get a positive 3 is equal to x. In other words, x is equal to 3. And our whole goal here is, again, to find what x, y, and z are equal to that make all three of these equations true. We were already given that z was equal to 4, but now we know that x is equal to 3. And now that we know that x is equal to 3, we can actually find y as well. Because if we go back to this equation up here, we get y is equal to negative 2 times x, which we now know is 3, plus 7. And we have that y is equal to negative 2 times 3, which is negative 6, plus 7, which means that y is equal to 1. And so our solution to the system of equations, numbers that make all three of these equations true, are z is equal to 4, x is equal to 3, y is equal to 1. And we would write our solution as x, comma y, comma z is equal to 3, comma 1, comma 4. And this is our answer for number 1. Number 3 is pretty similar. We're going to find the simplest equation we have. In this case, we're already given that y is equal to 3. And we're going to take this 3 and we're going to plug it into the other two equations if possible. Now, the top equation doesn't even have a y, and that's kind of nice. So really, we only have this y right here that we need for the second equation. If we substitute that in, the second equation is going to become negative 4x minus, instead of y, I'm going to write minus 3. Then plus 3z is equal to 18. But what I also want to do is I want to replace what I also know z to be equal to, which is x plus 3, and I'm going to replace z right there next to the 3. If we do that, this becomes negative 4x minus 3 plus 3 times z, which is x plus 6, is equal to 18. Now we have an equation entirely in terms of x, and we can simplify, combine like terms, all of that, distribute, and we can actually solve for x. So I'm going to bring down this minus 4x minus 3, and distributing the 3, we have 3 times x, which is going to be 3x, and then we have 3 times 6, which is 18, and that's equal to 18. Okay, so let's combine like terms. Let's see what happens. We have negative 4x plus 3x. That's going to be just negative x, so that takes care of those two. We have negative 3 plus 18, which is going to be positive 15. And then we have is equal to 18. So we're still trying to get x by itself, so we're going to subtract 15 from both sides. Minus 15 minus 15. That gives us negative x is equal to 18 minus 15, which is 3. And since we have negative x is equal to 3 and we need positive x, all we have to do here is just flip the signs on both sides. So if we flip the sign to be from negative x to positive x, we have to flip the sign here and make this positive 3 into a negative 3. But now we know that x is equal to negative 3. We already know that y is equal to positive 3. I kind of wrote over that. But we know that y is equal to positive 3. And now we just need to find z. But now that we know that x is equal to negative 3, z is just going to be equal to negative 3 plus 6. So z is equal to positive 3. And there we go. And so since we know what all three of our variables are, we have x, comma y, comma z is equal to negative 3, positive 3, and then also positive 3. A lot of 3's here. But this is going to be our solution. So all three of these numbers for x, y, and z will make each of these equations true. If we go on to the next one, number 5, we still have them easy where we still have one of our variables already given to us. So we already know that s is equal to 1, but now we have to use this information to find what r and t are equal to. So if I know that s is equal to 1, that's cool. I'm going to take that 1 and I'm going to substitute it now into both of the other equations. So now this is unlike the other two that we had, because now we have to substitute this into the other two equations. So if I take s is equal to 1, if I start with the first equation, I have r minus 2 times 1 minus 4t is equal to 14. That tells us that we have r minus 3 minus 4t is equal to 14. And now what I can do is I know that in the second equation we have that r is equal to negative 4s plus 4t minus 6. Well, first let me swap out that s for a 1 as well in the other equation. That gives us r is equal to negative 4 times 1 plus 4t minus 6. If I multiply negative 4 times 1, that's going to be negative 4 plus 4t minus 6. And then if I combine like terms, I'll write the t first. So I have 4t, and then negative 4 minus 6 is going to be minus 10. So I know that r is equal to 4t minus 10. And we also have from the second equation, r minus 3 minus 4t is equal to 14. So what I can do is I can take this and I can input it right there. And now I can swap out r for 4t minus 10. That's going to give us 4t minus 10 minus 3 minus 4t is equal to 14. That's going to allow us to get t by itself, and let's see what happens. At least we hopefully get t by itself. Because look at this. We have 4t minus 4t. Those are going to cancel. And we have negative 10 minus 3. That means we have negative 13 is equal to 14. And negative 13 is not equal to 14. That was false. And because this is false, that means that we don't actually have a solution to this system of equations. There are no numbers possible for r, s, and t that are going to make this system of equations true. So if you ever arrive at a contradiction, so I'm going to say, yeah, negative 13 is equal to 14. This right here is false, and therefore we have no solution to this system. Let's try number 7. Let's see what happens here. We're already given that c is equal to 1, so we're going to take this 1 and we're going to plug it into the other two equations if we can. Thankfully we can, so we're going to swap out c with what we know it's equal to, which is 1. If I take the first equation, we have 2a minus b plus 3 times 1 is equal to 12. That means that we have 2a minus b, and if I just multiply 3 times 1, that's going to be 3 is equal to 12. Okay, that's fine. I'll just leave that as is for now. I know that I can subtract 3. I can, simplify this a little bit, but it's not too important right now. What we want to also notice is that with the second equation, we have b is equal to 2a plus 2c. But because we know that c is equal to 1, I'm going to swap out c with 1, and then we have minus 11. If we do 2 times 1, that means we're going to have 2a plus 2 minus 11. And if we combine like terms here, that means we have 2a minus 9. So we know now that b is equal to 2a minus 9. And if b is equal to 2a minus 9, we can take this right here and substitute it in for the b that we see over in this equation. That will allow us to write this equation entirely in terms of a, and then we can hopefully solve for a. So if we try to do that, let's see what we get. We have 2a minus b, and anytime I'm substituting a variable, especially if I have a minus that variable, I prefer to put this in parentheses to make sure that we keep the signs correct here. Because watch this. If I didn't put this parentheses here, I would have 2a minus 2a, but we would probably forget to flip the sign on the minus 9 here, because if we do, you can think of this as like a minus 1 right here. If we have negative 1 times 2a, we get negative 2a, but then if I have negative 1 times negative 9, that gives us a positive 9, and then plus 3 is equal to 12. So see, if we didn't put the parentheses there, we would probably have written minus 9 when really this is going to turn into a plus 9. So that's just something to be cautious about. Usually when you're substituting variables, just put it in parentheses to be safe. But if we try to combine like terms, we have 2a minus 2a, and that's going to cancel out. So all we're going to be left with is 9 plus 3, which is 12, but that's also equal to 12. We don't have any variables left here. It's just 12 is equal to 12. And since this statement is always true, that tells us that this is actually infinitely many solutions. So we won't delve into what those solutions are, but what we do know is that there's infinitely many of them. So if we let c be equal to 1, there exists some numbers a and b that we can always choose that will make these equations correct, and that they'll always be right. So there's infinitely many points that will make, or choices of a, b, and c that will make this true. Hence, we have infinitely many solutions, and we can always determine that if we arrive at some true statement like a number is equal to itself. But it has to be a number equal to a number. It can't be, sometimes you'll see something like 3x is equal to 3, and that just means that x is equal to 1. That doesn't mean infinitely many solutions because it still has an x as a part of it. So it needs to be entirely a number equal to a number. Can't have any variables left in it. So something to consider when we're working through these. But let's look at now number 9. So number 9 is still not too bad. We still know that r is equal to -3. Let's see what happens if we substitute r in for the other two r's that we see in equations 1 and 2. We have an r there, we have an r there. Let's see what happens. For the first equation, we have -3 times -3 minus s plus t is equal to 6. If I multiply -3 times -3, that's going to be 9. I have minus s plus t is equal to 6. Okay. And again, I could move this 9 over to the other side, but it's not too important right now. What I want to do instead is substitute -3 in for the second equation as well, for this r. That's going to give us s is equal to r, which we know now is -3, plus 4t plus 3. And if I combine like terms here, this -3 and the plus 3 are going to cancel, and we're just going to get s is equal to 4t. Now that we know that s is equal to 4t, we can take this and we can input it into the other new equation that we had for equation 1. So we're going to swap out this s with 4t. That's going to give us 9 minus 4t plus t is equal to 6. If we combine like terms, -4t plus t is going to be -3t. We still have this plus 9 is equal to 6. And if I subtract 9 from both sides, I'm going to get a -3t is equal to 6 minus 9, since we're moving this over to the other side, and that's going to give us -3. We get t by itself by dividing by -3, and that's going to give us t is equal to +1. So we know that t is equal to +1. We know that r is equal to -3. Now all we have to do is find s. And so we can use this equation over here. We know that s is equal to 4t, and since t is equal to 1, we have 4 times 1, which means that s is equal to 4. Now we do want to write our answers in alphabetical order. Notice that these are all going to be, like if we go through the alphabet, R, S, and T. So that's the order that we're going to want to list them. You can also see that, either singing your ABCs, or you can just see that there are S and T. And all of these problems are going to organize the letters in alphabetical order. But R, S, and T, our solution will be -3, 4, and 1. And so, there we go. Now, what about 11? Okay, so things are getting a little bit harder now, because now we have some of our variables isolated, like we have x is equal to this, but we have y is equal to this. We want to hunt for the one equation where we only have one variable in it, and that's going to be the middle equation here. And then in the middle equation, we can get y by itself, thankfully, pretty easily. If we just divide by -4 on both sides, that means we have y is equal to -4 divided by -4, which means that y is equal to 1. And now that we know that y is equal to 1, it's just like what we were doing. We're going to take this 1 and we're going to substitute it into the other two y's that we see over here. So if we have y is equal to 1, let's see, if we go into this top equation right here, that means that x is equal to negative 1 plus 3z minus 7. And for the other equation, we have 1 is equal to negative 2x plus 2z plus 1. Now notice that this equation on the left already has x isolated. This is nice because that means that we can take this, what we know x is equal to, and we can input it into this x right here. What that's going to do is it's going to leave us with an equation entirely in terms of z, because there's only z's here, and then the one x in this equation is going to get swapped by z, so we'll only have z's in this equation. That'll allow us to solve for z. That's going to give us 1 is equal to negative 2 times negative 1 plus 3z minus 7. And then we have that plus 2z still, and then plus 1. And let's see what happens. Let's distribute this negative 2, combine like terms. Let's see. That has 1 is equal to 2 times negative 2 times negative 1 is going to be a positive 2. We have negative 2 times 3z. It's going to be negative 6z. And then we have negative 2 times negative 7, which is going to be positive 14. Plus 2z plus 1. And if I combine like terms, we have this minus 6z and this plus 2z. Still have the 1 right here, but these two z terms are going to combine into a negative 4z. That takes care of those. And then if we have 2 plus 14 plus 1, that's going to be 17. Now we're still trying to get z by itself, so let's move this 17 over to the other side. We're going to subtract 17, and if we subtract 17 from 1, that's going to give us negative 16 is equal to negative 4z. And now we can find z by dividing by negative 4 on both sides. That means z is going to be equal to negative 16 divided by negative 4. It cancels, and negative 16 over negative 4 is going to be a positive 4. Now that we know that z is equal to positive 4, we can go back to this equation and we can find what x is equal to. X is going to be equal to negative 1 plus 3 times 4 minus 7. And now we have negative 1 plus 12 minus 7. And if you throw all of this into your calculator, x will be equal to, let's see, that'll be 12 minus 8. And so that'll be positive 4. And so our solution here, we're going to have x comma y comma z is equal to 4 comma 1 comma 4. And this is our final answer. All right, we have 2 more and then we're done with this video. So same as before, we want to find the equation with only one variable, or at least the least amount of variables. In this case, that's going to be t here in equation 3. Notice that we can get t by itself if we just divide by 5 on both sides. So if we do that, we get t is equal to 25 divided by 5, which means that t is equal to 5. So we know that t is equal to 5, and now we can take that 5 and we can input it into the other two equations. We have a t there and we have a t here. So inputting that into the other two equations, the first equation, we're going to get s is equal to 4r plus 2t. We know t is 5, and then plus 1. If we multiply this out, we still have the 4r, but 2 times 5 is 10, and then plus 1 the 10 plus 1 will combine, and we're going to get an 11 out of that. So now we know S is equal to 4R plus 11. For the other equation, since we know that T is equal to 5, swapping that out, we have 5 is equal to negative 4R minus S minus 2. So let's see. Well, we know that S is equal to 4R plus 11, so we can just input that over here where we see an S. And that's going to get us an equation entirely in terms of R, because there's only an R there, there's only an R there. And so that means we have 5 is equal to negative 5R. And in parentheses, I'm going to write the minus 4R plus 11. We don't want to mess up the sign right here. And then minus 2. If we distribute this, again, think of this as like a negative 1. We're going to have negative 5R. Negative 1 times 4R is going to be minus 4R. And then negative 1 times 11 is going to be minus 11 minus 2. We want to combine like terms. We have negative 5R minus 4R. It's going to give us negative 9R. That takes care of those two. And then we have negative 11 minus 2. It's going to be negative 13. If we add 13 to both sides, because we're still trying to get R by itself, that's going to be 18 is equal to negative 9R. And now all we have to do is divide by negative 9 on both sides. And if we divide by negative 9, that cancels. And 18 divided by negative 9 is going to give you negative 2 is equal to R. In other words, R is equal to negative 2. You can always switch the sides of an equation to make it look a little bit more familiar. But now that we know that R is equal to negative 2, we can swap out R for negative 2 in this equation up here to find S. So if S is equal to 4 times R, that's going to be 4 times negative 2 and then plus 11. 4 times negative 2 is negative 8 plus 11, which means that S is equal to 3. And so again, keeping all of these in alphabetical order, we have R, S, and T. R is going to be negative 2, S is 3, and T is 5. And there we go. So that's how we do number 13. And the last one, let's look at number 15. So again, we're going to try to find an equation that has only one variable in it there. And in this case, that's going to be the first equation. We can get y by itself just by dividing by 4 on both sides. That's going to give us y is equal to negative 12 over 4, which means that y is negative 3. Now that we know that y is equal to negative 3, we can take this negative 3 and we're going to swap it everywhere we see a y in the other two equations. We have y there, we have a y there. So if I start with the middle equation, that means that we have z is equal to x plus 2 times y, which is negative 3, plus 3. What we can then do is we can just multiply 2 times negative 3. That's going to be x minus 6. We have a plus 3, and we can go ahead and combine these. That's just going to be x, and then minus 6 plus 3 is going to be just minus 3. So we know that z is equal to x minus 3. What we can do is we can also look at this bottom equation, the x is equal to 6y plus z plus 21. We do want to swap out that y with negative 3 real quick. That's going to give us x is equal to 6 times negative 3 plus z plus 21. If we multiply 6 times negative 3, that's going to be negative 18 plus z plus 21. And if we go ahead and combine the negative 18 and the 21, that's just going to be 3 plus z. Okay, so it doesn't matter which one we plug into the other. Since we know that z is equal to x minus 3, I'm going to take this and we're going to input it right there. So since we know that z is equal to x minus 3, let's swap out this z with x minus 3. And let's see what happens. We get x is equal to 3 plus x minus 3. 3 minus 3 is just 0, and that leaves us with x is equal to x. Now what you can do is you can try to subtract x from both sides, trying to move this one over to the other side, but all you're going to end up with is 0 is equal to 0. So if you end up with 0 is equal to 0, because this is true, we have infinitely many solutions. And that's our final answer for this problem. All right. So, as usual, your homework is the evens. So, thank you for watching. I'll see you in the next one.